The first question asks us to fill in the missing lines in the three regular views. We recognize the three regular views as the front view, the top view, and the right side view. To develop the front view, we imagine looking at the object through the frontal viewing plane. To solve this problem, we'll use three important facts presented in the unit on regular views. First, if a visible surface is parallel to the viewing plane, it will appear in true size and shape in the corresponding regular view. In this case, we're looking through the frontal viewing plane, which corresponds to the front view. Two surfaces, here and here, are parallel to the frontal viewing plane, so they will both appear true size and shape in the front view. Looking at the front view, this surface appears to be correct, but this surface is not. Where this surface meets the inclined surface, there should be a visible line in the front view, here. The second fact is that surfaces perpendicular to the viewing plane appear as lines in the corresponding view. This surface is perpendicular to the frontal viewing plane, and it appears as this line in the front view. This surface is perpendicular to the frontal viewing plane. It appears as this line in the front view. This surface is perpendicular to the frontal viewing plane. It appears as this line in the front view. Similarly, this surface is perpendicular to the frontal viewing plane. It corresponds to this line. This surface is perpendicular, corresponds to this line. This triangular surface is perpendicular. It corresponds to this line. And if we could see around the back, what we would see from the left side view is perpendicular to the frontal viewing plane, and it appears as this line in the front view. The bottom surface is perpendicular to the frontal viewing plane, and so it appears as this line. The third fact is that surfaces inclined to the viewing plane appear as foreshortened surfaces in the corresponding view. The only other surface visible in the front view is inclined to the frontal plane, so it appears foreshortened in the front view. Since all the surfaces are accounted for in the front view is complete. Next, we look at the top view. To develop the top view, we look down at the object through the horizontal viewing plane. When we do so, we see 1, 2, 3 surfaces that are parallel to the horizontal viewing plane. These should all appear true size and shape in the top view. So this surface, and this surface should be represented true size and shape. Now there are also several surfaces that are perpendicular to the horizontal viewing plane. Of course, the perimeter surfaces are represented by the visible lines at the perimeter of the top view. We also have this surface is perpendicular to the horizontal viewing plane, and it should therefore be represented by a line in the top view, and it is. This surface is also perpendicular to the horizontal viewing plane, and it should be represented by a line, and that's here. So we now have taken care of all the parallel and perpendicular surfaces to the horizontal viewing plane. That leaves this surface, which is inclined, and it appears again as a foreshortened shape in the top view. Since we have accounted for all of the parallel, perpendicular, and inclined surfaces to the horizontal viewing plane, the top view is complete. Next, we'll look at the right side view. To do that, we have to look through the profile viewing plane from the right side. Once again, we will apply these same three principles. Surfaces that are parallel to the profile viewing plane should appear true size and shape in the right side view. Surfaces that are perpendicular to the profile viewing plane should appear as lines in the right side view. They could either be visible or hidden lines. And finally, surfaces that are inclined to the profile viewing plane should appear as a foreshortened surface in the right side view. So looking through the profile viewing plane, we should look for parallel surfaces. Here's one, and here's one. These should all appear as true size and shape surfaces in the right side view. We see this surface. We only see one surface, so we're not distinguishing in the right side view between this surface and this surface. If we take a look at this surface, notice it's perpendicular to the profile viewing plane, that means it should be represented there by a line, and that line would be right here. This perpendicular surface interrupts the two parallel surfaces, and we see that with a line here in the right side view. So that accounts for this surface and this surface, but this triangular surface is parallel to the profile viewing plane, and so it should appear true size and shape in the right side view. It should appear as a triangle. So this line is missing. Now just for a check, let's take a look at perpendicular surfaces. Here's one, perpendicular to the profile viewing plane. It should be represented as a line in the right side view, and it is. And this surface is also perpendicular to the profile viewing plane. It's represented by this line. The rear surface is represented by this line. It's perpendicular to the profile viewing plane. The bottom surface is perpendicular to the profile viewing plane. It's represented in the right side view by this line. And this front edge is perpendicular to the profile viewing plane, and it is represented by this line in the right side view. So we have accounted for all of the parallel, perpendicular, and inclined surfaces in the right side view, and so we are done with the right side view. Now, since we've looked through each viewing plane, the frontal viewing plane, the horizontal viewing plane, and the profile viewing plane, and in each case we've accounted for all the surfaces in each of the three views, we can be confident that we have now added all of the missing lines in the three regular views as the question asked.